So in this video, we're going to write the equation for graphs, and we're going to write them into vertex form. So essentially, we're going to get some key information about that graph, and we're going to take that key information and then be able to write that equation in vertex form. So before we start writing equations into vertex form, let's remember what vertex form looks like. In vertex form, essentially what we need to find a value for A, we need to find a value for H, and we need to find a value for K. So the X and Y are always there as X and Y, and we need to make sure that we have values of A, H, and K to go into that equation before it will be complete. So here we're going to write the equation for a parabola with a vertex of 3, 5, so that's a key piece of information, and it also goes through the point 2, 3. So that's kind of our goal. We want to write the equation that has the vertex of 3, 5 and goes through the point 0, 3. And while that seems a little daunting, it's actually not as daunting as you might think. So remember, we need to find values for A, H, and K. But what's really, really nice is if you remember, H and K are directly related to the vertex. H is the opposite of the x-coordinate of our vertex. So our H is really the opposite of that 3, which is a -3. And our K is the y-coordinate of our vertex, so our K is 5. So what we can actually do to start off right off the bat is we can identify values for H and for K and substitute them into our equation. So here we have y is equal to, I don't know A yet, but I do know that my H value is -3 because it's the opposite of the x-coordinate in my vertex. So this is x plus -3 squared. And then my K value is the y-coordinate of my vertex, so it's plus 5. So I've actually been able to find 2 of those missing 3 values just by looking at my vertex. Now this last step, what we can actually do now that we only have one missing value that we need to find, is we can take this point and we can say, well, let's find the A value that makes that point work for X and for Y. So at this point, we're going to temporarily fill in X and Y with this point because this point has to work in this equation. We're going to substitute 2 in for X, and we're going to substitute 3 in for Y, just temporarily, so that we can find our A value, because we need this point to work with our A value. So here if we substitute this in, we have 3 is equal to, A is staying the same. I then have 2 plus -3 squared plus 5. So now if I start to simplify this a little bit, I know I can simplify these parentheses here. So this would become A times, that's a -1 squared. I can then square that, so this is really A times 1. So I really have 3 equals 1A plus 5. And then if I want to get the A alone, all I need to do is subtract 5, subtract 5. So I find that A is really equal to -2. So the A value of -2 is what makes that extra point of 2, 3 work. So now I can take this and I can substitute that back into my equation for my quadratic. So my final equation, if I take what I already know here about H and K, we have y is equal to, my A value is -2. Then I have x plus my H value of -3 squared plus my K value of 5. And there is my equation for a quadratic that will have the required vertex and go through the given point. Alright, so let's try another example here. So here we see it's a different problem. We have a vertex of 5, -2, and we go through the point of 3, -6. So to start off, let's see what values of A, H, and K we can fill in right off the bat. So remember that my vertex is the opposite of H, K. So my H value is going to be the opposite of that 5. So h is -5, and k is exactly that y coordinate, so k is -2. So I can already plug 2 of those values into my equation. So let's start with that. So we have y is equal to a, parentheses, x plus -5, then you can put plus -2 or -2 on the outside, and then don't forget your squared next to those parentheses. So that's what we know so far, and that's as far as we can currently get. Now, what we can do is we can again take this point and say, well, my equation, whatever my equation is, the a value needs to make this point of 3 comma -6 work. So temporarily we're going to put 3 in for x and -6 in for y, and our hope is that we will find the a value that makes the equation true with that particular point. So let's go ahead and get started with that. So we're going to plug -6 in for y temporarily. We have a, then we have x is temporarily 3 plus -5 squared plus that -2 on the outside. So let's simplify this a little bit parentheses wise. So we have, that's -2 squared, and then this can be simplified a little bit, so that becomes a times 4, and so really this is -6 is equal to 4a plus a -2. So then let's start off here and let's add 2 to each side. So we have -4 is equal to 4a, and if I divide both sides by 4, I essentially discover that my a value is equal to -1. So I can now take that, plug it into my equation, and now I've found values of a, h, and k for my quadratic. So I can go and I can now take these values of a, h, and k and put them into my equation. So we have y is equal to -1 for a, x plus -5, quantity squared, plus -2. Now if you don't like the keep, change, you could also write y is equal to -1, x minus 5 squared minus 2. Either of these would be fine depending on whether or not you like using plus and negative or you'd rather use subtraction instead.